Let's start this series off with a simple fact. You are attractive. Literally. You are made up of matter, and that matter gravitationally attracts all other matter in the universe. But on a cosmic scale, you are pathetically tiny, so your attractiveness pales in comparison to something like this gorgeous body. We usually see that level of gravitational attraction referenced in movies by people or spacecrafts falling to their doom, into stars, into black holes, towards the surface of a planet. The amount of gravitational pull you feel from another object in space depends on three things: your mass, its mass, and the distance between your centers of mass. A larger mass, more pull. Further distance, less. When I throw this apple, Earth's gravity pulls it back to the surface at an acceleration of 9.8 meters per second per second. We call that 1g. If this apple and I were inside a dead-in-the-water spaceship 100,000 kilometers from Earth, we would be pulled toward the planet starting at only 0.04 g. As we get closer to Earth, gravity would get stronger, and the acceleration would increase. But the ship is under the same pull as I am, the same pull as the apple is, so we all fall together. I wouldn't, for instance, slide through the ship. It's the same for even more massive objects like stars, except at equal distances, the larger mass causes higher acceleration. On a small moon, I said moon, the gravitational tug is significantly less than what you're used to. That's why footage shows astronauts not only jumping much higher, but also falling back down much more slowly. If the object is small enough, like a comet, gravity is so weak you could accidentally get forced away from the surface fast enough that you'd fly off of it into the void of space, never to come back down. But of course, replicating gravity for a movie is time-consuming and therefore expensive, and it's frequently irrelevant if not counterproductive to the story. Of 22 movies that represented people walking on small rocky bodies, only 4 gave accurate representations of lower gravity. An additional 4 films were inconsistent between scenes, showing fractional Gs in one or just a few select scenes. It might be easy to think of everything in outer space as weightless. Both real NASA footage and movies show astronauts on board spacecrafts playing with food or doing somersaults midair. A few minutes after launch, characters get out of their seats and start floating around as if gravity had just turned off all of a sudden. For the Earth is still right there. The International Space Station, for example, is only 400 kilometers above Earth's surface, not that far away from a very massive body. The station and its inhabitants feel the gravitational pull only 10% less than what they do on the ground. The only thing keeping it from falling back to Earth is its orbit. It travels horizontally so fast that, even though it's constantly falling, the land beneath it curves down at the same rate. The astronauts inside are all still well under the influence of gravity, but they wouldn't be able to register weight on a scale because everything is falling together. That's one definition of weightless. The other, of course, you'd experience if you were all by yourself out in the void of space. If there's nothing for you to be gravitationally attracted to, you can't have a weight. If a spaceship could get far enough away from all astronomical bodies, gravity would be so weak it's effectively, but technically never exactly zero. Astronauts want to avoid long-term exposure to either form of weightlessness, due to its negative health effects on the human body. Movie makers want to avoid it for entirely different reasons. You can probably guess what some of those are. Movies that exclusively show characters weightless in outer space usually either spend very little time in space, or they keep the characters strapped in so tightly to their seats that they don't get to move around during the journey. Another technique is to keep the shots very tight and have the actors balance on some sort of lever, or even just slowly move around, pretending to float. Apollo 13 is an interesting separate case because the weightless scenes they shot were actually done in 0G. They flew in one of NASA's reduced gravity aircrafts, a plane that flies in parabolic arcs to simulate weightlessness. You might also know it as the Vomit Comet. For about half a minute every arc, everything is in freefall, but it took the cast and crew 612 arcs to get the footage that they needed, and that's just not going to cut it for most films. So, they make use of artificial gravity. The easiest way to do this, of course, is to completely ignore the matter. But you could at least invent some vague technology referred to as artificial gravity, and that allows people to move around like they would on Earth. This form of artificial gravity is very much rooted in genre. Movies classified as action, adventure, comedy, horror, and especially fantasy are far more likely to employ this method because it best serves the tone of the story being told. Unless a moment of tension is needed while the artificial gravity is turned off, they set scientifically accurate gravity aside for the sake of their pacing and their plots. But there is, of course, a more visually enticing way of generating artificial gravity. It calls upon basic Newtonian physics, and was perhaps most famously used in 1968's 2001. However, it would be another 16 years until the next example, and of the 11 films that used rotation to mimic gravity, 7 of them were made in this century. Of those 11 films, we also see a lot of action and adventure movies, but that's just because most of the 90 reviewed movies classified as either action or adventure. But based off percentages, 42% of thrillers, a third of mysteries, and nearly a quarter of dramas use this method of mimicking gravity, whereas only 7 and 8% of action and adventure movies did. It makes me wonder if a more scientifically grounded spacecraft helps keep that drama, that so-called thrill, more intense. But I suppose it's going to depend on where the movie is driving its tone. Does it come from the dangers of space itself, or is it because you've got a homicidal lunatic on board your ship? It's food for thought. Thanks for watching the first of this 4-part video series. Up next, we're going to be talking about a subject as big as the universe itself. Literally, because I'm talking about how big the universe is. But if you're done watching, and you'd like to help me out with my dissertation, please click on the link here or in the description below to give feedback.